Okay, we're now on to section number 4, which is looking at Pythagoras and trigonometry. I think on the front of the booklet, I've just noticed it just said trigonometry, but it is Pythagoras and trigonometry. So it's a mixture of both of those there. Now, question 20 says this. Okay. Also, guys, if you're using these videos, I'm so glad you're using them. So keep it up. I really appreciate it. Hopefully that they are useful. And any questions, of course, you can always comment. But hopefully they're quite useful. Anyway, question 20 says, here you've got a right angled triangle, okay, and Pythagoras and trigonometry on these questions is all to do with the right angled triangles, not trigonometry at the grade 7 level, which is non-right angled triangles. Anyway, it says, use Pythagoras to show that x, so this side here, is equal to 0.8. Now, first of all, I would always write down every single time Pythagoras' theorem, okay, in this case. So you're going to state that the theorem is a squared and b squared is equal to c squared, okay? Where A, B, and C are your sides, and C is always the longest side, the hypotenuse, which is always opposite the right angle. So that's going to be side C. And then these are your two shorter sides, okay, x and 1.5, A and B, and the order here does not matter. So if I call that A, that can be B. The order is irrelevant. So I've got A squared, where A is x, so kind of substitution now, I've got x squared plus b squared, where b is 1.5, so plus 1.5 squared, is equal to c squared, where c is 1.7 squared. Okay, now just kind of clearing everything up here, I've got x squared, 1.5 squared is equal to 2.25, and 1.7 squared, I've forgotten, I should know my 17 times table, but I've just forgotten it, so 1.7 squared, okay, so 1.7 and then squared gives me this 2.89, yeah, 289. That's good. So 2.89. Now I've got to go and find the value of x here. I'm going to go and take away 2.25 onto this side. So x squared is going to be equal to 2.89. Take away 2.25. Okay, so x squared is going to be equal to 2.89, take away 2.25, which gives me this, okay, 0.64. Now that's x squared. To go and find x, I've got to go and square root 0.64, which does indeed give me 0.8. Okay, so when you get given a show that question, they give you the answer. You just work towards it as normal. And actually, these are good questions because they give you the answer. And if you get the wrong number at the end, you've gone wrong somewhere. So that's definitely correct. Okay, it equals 0.8. And just to be a little bit fancy here, you can write as required. Okay, you've proven that the answer is 0.8 as required in the question using Pythagoras' theorem, which always write it down. Good. And then what's going on here? Sorry. Question 21 is below. It says, use trigonometry to work out the value of x. Okay, so this time it's going to be trigonometry. There we go. And it's x. Now, the first thing you want to do with trig is always label up your sides, okay, with regards to the angle. Now, the side opposite the angle, you go and call it the opposite side. So opposite. And then the longest side is your hypotenuse, always opposite the right angle. So that's going to be the hypotenuse. Now, the remaining side is the adjacent side. Now, because there's no information given on this side, there's no length and there's no missing variable, unlike the hypotenuse and the opposite, leave it blank. I wouldn't bother labeling it A because it just causes confusion with which ratio to choose. So just to really quickly recap there, because I've not taught you guys trig before, and I'm not quite sure what your trig stuff is like. If you're given a right angled triangle, okay, if this over here is the angle, that's the Greek letter theta, the side opposite the angle is called the opposite side O. The side opposite the right angle, the longest side, is called the hypotenuse, and the remaining side next to both of the angles, you call it the adjacent side. Okay. Now again, because there's no length or anything given here, leave it blank. Now you've got your kind of acronym to remember your trig ratios, which is SOHCAHTOA, SO, CA, and then TOA. And personally, I'm a big fan of using the trig triangles. Now because I can, I just dropped my pen. because I can see on my question, I've been given here the opposite and the hypotenuse. Which one of these has got both O and H in it? Well, it's not TOA. I've got no H here. Ka has got no O in it. And So has got both O and H. O and H. So this is the trig ratio that I want to be using. Now, what I'd always go and do next is I would draw my triangle to help me get the formula correct. So this thing over here. And I'm really going through this slowly because I'm assuming that you've not done trig in a while and you've forgotten it. I'm sure you haven't. I'm sure it's pretty good. But just in case we are rusty, I'm just really going through it slowly. Now, the middle letter always goes at the top of the triangle. So that O goes up here. Now, this S, this is quite important, it's not just S. Do not just go and write this. That's not useful. The S stands for sin or sine of the angle. So that's really important. So S is sin of the angle, C would be cos of the angle, and T would be tan of the angle. And then the H goes down here, over here. Now, in the question, I'm trying to find the value of X, which is the opposite side. So X is the missing thing, which is the opposite side. You put your finger over that part of the triangle. Okay, so literally, if you want to, put your finger on your screen or on your computer screen and cover it up. And write down that O is equal to. So whatever you cover up with your finger, in this case it's O, put it equal to. And then it's going to be the parts below, sine theta multiplied by the hypotenuse. So sine theta times H. So this part's covered up. You've then got sine theta times hypotenuse. So I would always write down the formula, sine of the angle theta times hypotenuse. And then from here, it's just substitution. O is X is what you're trying to find. So you can replace O with X is equal to sin of the angle, and the angle in the question is 40. So sin of 40 multiplied, and make sure you close the bracket with that 40, multiplied by the hypotenuse, H is equal to 21. So multiplied by 21. And then from here, you just got to go and put it into your calculator carefully. And we've got sin, I can't do that, can I? I've got sin 40, close the bracket, multiplied by 21, gives you this. Now, did it ask for anything rounding in particular? I can't remember. Let's have a look. No, you can round it to whatever you want to. So let's go for 13, 13.5 to 1 decimal place. I always think, like, does this make sense? Is that a reasonable answer? Yeah, it seems pretty reasonable. If the hypotenuse, which is my longest side, is 21, or 13.5, it looks reasonable. So that's going to be a good answer. Okay. Good, I'm going to really go through these questions slowly because I'm just assuming that we're rusty on this topic. I don't want to just rush through it and then it not make any sense at all. Okay, so hopefully it is useful. Question 22 is you've got a diagonal of a rectangle is 23.7 centimeters long. So let's just draw this out. Yeah, I'm not even looking at any mark schemes or anything here. We're going through it like you would do in the exam. So you've got a rectangle over here. There we go. And the diagonal of the rectangle, this part here, is equal to 23.7 centimeters, and that's going to be a right angle. Okay, so that means immediately it's going to be Pythagoras or trigonometry. The diagonal makes an angle of 52 degrees. Okay, so it makes an angle here of 52 degrees with a side length of x centimeters. So the diagonal, this here, makes an angle of 52 degrees with a side length of x. So with this length here being equal to x, because the angle is made between 23.7, this diagonal here, and this length here, x. Work out the value of x. Okay, so let's go through and do that. Okay, so if you want to, you can just kind of redraw this triangle here to make it clearer to yourself what is going on. Let's go and do that to make it really clear. So we've got this over here, this down here, and then this over here. That's my right angle. There we go. Where this here is 23.7, that's 52, and this here is my missing side length x. Now this is not Pythagoras. Pythagoras is only to do with missing sides. You've been given an angle, so it means it's trigonometry, which means, okay, and this is quite useful, we can zoom out a little bit, it means it's going to be using the trig ratios up here, so, ka, and so. Now again, we're going to label up our triangle here using our trigonometry labelings. So you've been given the angle here. The side opposite the angle is the opposite side, okay, O. But again, there's no information at all on this side, so I would always leave that one blank. Don't label it. But this side here is the hypotenuse because it's opposite the right angle, and the remaining side must be the adjacent, which makes sense because it's adjacent to both of the angles. So this time, you've got A and you've got H, which is K, because you've got A and you've got H. So this time, I'm going to go and circle this part of the acronym, K. And again, we're going to go and draw the triangle for this. So, okay, there we go, there we go, and there we go. Now this time, okay, the A, the adjacent side, goes at the top of the triangle. So it's always the middle letter goes at the top, A, and then the C stands for cos of the angle. So you're looking at the calculator over here, you've got S as sine, C as cos, and T as tan. So in the little triangle, we've got cos of the angle theta, and then the remaining part, the H, goes down here. Down here. Now, on this triangle, we're trying to find this value of x here, which is the adjacent side. So this time, you put your finger over the A, and you say that, well, A is going to be equal to, so put your finger and cover it up, using the equation triangle, it's going to be cos theta times the hypotenuse. So cos theta times the hypotenuse. And then you just substitute in your values. A is equal to x. So x is equal to cos of the angle theta, well, the angle is equal to 52. So cos 52 multiplied by the hypotenuse is equal to 23.7. So multiplied through by 23.7. And then you just got to go and put this into your calculator. So let's go do that. So cos 52 multiplied by 23.7, which gives us this. And hopefully, what question is this? Question 22. Yeah, 14.6. I'm going to round it to, okay, 14.6 to 1 dp. There's no required rounding, it just says work out the value of x. And looking at the mark scheme, hopefully, yeah, that's fine. You can round it however you want to, but that's fine. Okay, so there we go. Good. Question 23 is this time is saying use Pythagoras. Okay, so straight away, right in the exam, you get down a squared add b squared gives you c squared, and you label your triangle up. So again, in Pythagoras, the longest side opposite the right angle, you call it C. Your two shorter sides are called A and B. It just says work out the value of x, and they tell you to use Pythagoras, so it should be quite straightforward. Okay, so the value of A for our triangle here is 17.2 squared add b squared, where b is 12.9 squared, is equal to c, which I've called x, so x squared. Let's just go and put this into the calculator and simplify it all up. Okay, so let's go and do that over here. So I've got 17.2 squared add 12.9 squared gives me this. So 462.25. So 462.25 is equal to x squared. But that's x squared. You've got to go and get x, so you've got to go and square root this number. Okay, 462.25. And if I do that, okay, so I'm going to just go and put this and root the answer. And there we go. I get this 21.5. Okay, and I always think, does that roughly make sense? 23, let's put the marks, I'm sorry. 23 is, yeah, good, 21.5. Does that kind of look like it's going to be a good answer? Yeah, because look, this is the hypotenuse, which has got to be the longest side, and 21.5 is bigger than both of these sides, and it's not unreasonable. So that seems pretty good to me. Perfect. Okay, question 24 is, this is a nice question. Bit more high level question, but it just says work out the size of the angle x, and it doesn't tell you whether to use Pythagoras or trig. So you want to work out this angle here. Now, if you're given right angle triangles, which you are, you've got triangle ABC, which is right angled, and triangle ACD, which is a right angle, it's going to be either Pythagoras or trigonometry. Now the thing is, if I look at triangle ABC, I'm going to go and draw this one actually. Okay, ABC over here. So A, B, let's go and redo that, sorry. A, B, and then C, where this here is the right angle. Okay. Well, the thing is, I've got this, I'm trying to find this angle X here, and this side is 9.3. I haven't, and this is going to be trigonometry because I've got an angle here. I have not got enough information here to work out the angle. I need another side at least. I need either this side, which is side BC, or this side here, AC. Now, that's where this triangle ADC will come into play, because I can work out this side here from this triangle, ACD, which I'm going to go and draw it in green. So let's go down here, and then over here, and then over here. This one, I'm giving this to be 37 degrees, and I know that's going to be 4. And I'm going to go and call this side here, I'm going to go and call this side here, AC, my missing side X. If I can find this side, which is side X, it's the same length as this side, which I can then go and use in this triangle. And this is, of course, going to be trigonometry, because I've got an angle with sides. So let's go and label up my triangle. Now, again, the side opposite the angle is called the opposite side, but leave blank because there's nothing there. This must be the hypotenuse because it's opposite the right angle. That's my hypotenuse, and that must be the adjacent. And again, I'm always going to write out now my SOHCAHTOA. Okay, so, ka, and then toa. Now in this one, I've got A and H, which is ka, A and H. So I'm going to go and circle this one. I'm going to show out the working every single time. I'm going to go and make sure that I draw my equation triangle. There we go. Over there and over there. And let's get rid of the calculator over here. Let's put it onto this side for the time being. Okay. And we know that, well, the A, the adjacent side, goes at the top of the triangle. The C stands for cos. If you forget, it's on your calculator. Right, C is cos. And it's going to be cos of the angle, and the H must go down here. Now we're trying to find in this triangle, we're trying to find the adjacent side, which is X, because X is our missing thing. I've called it X because if you're trying to find something in maths, give it a letter. And A, again, put your finger over A and say, well, that A is going to be equal to cos of the angle theta multiplied by the hypotenuse. So cos of the angle theta times the hypotenuse. A is equal to X, so X is going to be equal to cos of the angle, which is 37, multiplied by the hypotenuse, which you can see is 4. So times it by 4. So X is going to be equal to cos 37, times that through by 4, and we get this. And at this stage, I wouldn't round too early. I'm going to keep it as 3.19454, because I don't want to round it too early. But this is now good, because this side here is what I've just found, X, which is 3.19454. So on my diagram over here, I'm going to go and label this side to be 3.19454. And now, right, I can put it onto this diagram, because that's length AC, which is over here, AC. So that's going to be, I'm just going to go and label it as 3.19, otherwise it'll get too messy, but that's fine. 3.19, which you can't really read. So now we're going to look at this red triangle over here, and we're going to go and label up the sides again. So here's my angle. I've now got the opposite side given over there, this side O, and I've got the hypotenuse opposite the right angle. And there's nothing on this side here, so leave it blank. Now this time I've got the opposite with the hypotenuse, okay, O and H, which means I'm going to be using SO, okay, because I've got O and H. So straight away, you're going to go and get your equation triangle drawn out for this one. Okay, there we go, and there we go. Where this time the O will go up here in the middle, so O, and then it's going to be sine of the angle, and the H goes down here. Now we're trying to find this time the missing angle, okay, the angle part, and the angle part is the theta part. So this time you're going to put your finger over this part of the triangle, and write down sine theta. So write down sine theta is equal to, okay, and if your finger's covering this part on the screen, it's going to be the opposite side divided, that means divided by the hypotenuse. So opposite divided by hypotenuse. This means divide. And then we're going to put in our values. So sine of the angle, or the angle's x, that's what I'm trying to find. Now really actually this was a bit poor from me. Because the angle is labelled as x, I should have used a different letter for this side here, such as y or anything other than x, but truthfully doesn't make a lot of difference, but just like notation, right? If I've called this angle x, I didn't even look at it properly, I should have used a different letter for this side here. I didn't, I called it x, apologies. Now, sine of the angle theta, which is x, is going to be equal to the opposite side. Okay, and the opposite side here is this number, 3.19, but don't write it in short, write it as 3.19454. I'm going to divide this through by the hypotenuse, okay, which is 9.3. There we go. Okay, so actually, because that's going to annoy me otherwise, I'm going to get rid of this here. I'm actually going to go and call this x here. Let's go and call this one y, just because it should be really be written as y. So this, I'm going to go and label it as missing side y. Okay, so and then this one was this. Nothing's changed really, guys. I shouldn't use the same letter for a side and the angle because they're different things. Okay. Anyway, right now I'm just going to go and simplify this a little bit and say that I've got sine x is going to be equal to 3.1454 divided by 9.3, and it should be less than 1, which it is, which is good, which is this number, 0.3434, so on and so forth. Now, that is the value of sine x. Clearly, this angle is not equal to 0.3434, blah, blah. To find x, I'm going to go and do that inverse. So to find x here, I go and do the sine inverse. Whenever you're trying to find an angle, you do the inverse of that trig function, and then you put in 0.3434, dot, dot, dot. Okay, and then putting it into my calculator. Okay, so clear this. You've got to go and press shift and then sine, and then your number is 0.3434. I should have really used some more decimal places, but that will be fine now. Press equals to, and the answer is 20.1 degrees to 1 dp. So the answer is 20.1 to 1 dp. Okay, and hopefully I made that really clear. I'm going to zoom out so you can see everything on the screen there and just kind of centralize it. Yeah. So that was question number 24. 24. Yeah, that is correct. And hopefully that made sense. It's just applying trigonometry twice, guys. Okay, and that will be worth quite a few marks in the exam. Probably 4 marks. I can't see where it is on here. I think it's a 4 marker. Yeah. Yeah, 4 marks. Okay, there you go. Perfect. Okay, question 25 is down here, and looks like a nice one with a bit of ratio as well. It says, here is a right angled triangle. A is 16, so this side here is equal to 16. It says a ratio of A to C is 4 to 5, so that's going to make a note of that. A to C, the ratio here is 4 to 5. And you know that A in the question is equal to 16, so what I can go and do here is upscale. Okay, so I'm not even reading the question, I'm just kind of thinking, what can I do here? From 4 to 16, I'm timesing through up there by 4. Do the same thing over here, times through by 4 to give me 20. Okay, so the length of C in this question must be equal to 20. So C must be equal to 20, okay? And it says work out the area of the triangle. Now to get the area of a triangle, this is quite a nice question actually, you need to do, of a right angle triangle, you do the base times the height and you half it. So the area is going to be, let's get rid of the calculator, otherwise it will overlap. The area is going to be equal to half, because remember a triangle is half of a rectangle, half times the base times the height. So what you need to go and do is you need to find the base here. because you've got to do the base times the height and half it. You don't need the diagonal length to find the area of a triangle, but it's got to recognise that you've got to use Pythagoras here. So to find, I'm going to draw a new triangle. To find this length down here, okay, let's go and call this side x. I'm trying to find this one. That's 16 and that's 20. I've got to use Pythagoras here because all two have sides. Side C, my hypotenuse, and side A and B are my two shorter sides. And I would always write down the formula, a squared and b squared gives me c squared. And again, we substitute our values now. So a is equal to x. So I've got x squared add b squared, which is 16 squared, is equal to 20 and then squared. So I've got x squared plus 16 squared is 256. I'm just going to double check that, but that is correct. 99% short, so 16 times 16, yeah, good. Okay, is equal to 20 squared, which is 400. Now to go and find, what's happened there? Sorry guys, here we go. Okay, is it all okay? Yeah, I think we're fine, sorry. Now to go and find x squared, I'm going to go and take away that 256, so 400 take away 256, which is going to be 144. Okay, so it's a nice Pythagorean triplet because the square root of 144 gives me 12. So this length here is going to be 12. So using the formula over here, okay, well the base now is 12, so it's going to be 12 multiplied by the height of the triangle, which is 16, and then we go and half this. Okay, so 12 by 16 is going to give you 160 add 32, which is 192, and we're doing half of 192, which gives us 96 centimeters squared, and that should be correct. And that's number 25. Question 25, 24, 25. So the mark schemes are really hard to follow. 25, 23. So we've got that. 12. I mean, I can't see. Sorry, the way I've printed the mark scheme, it's a bit all over the place. So I'm just going to double check. Right, we've got the base, which is 12. 12 times 16. Yeah, divide that by 2. Yeah, 96. Perfect. That's going to be correct. Okay. So that's this one. Question 26 is this one over here. It says, here is a shape made by using a right angle triangle and a rectangle. So there's your right angle triangle and there's the rectangle. Work out the area. So let's begin by finding the area of the triangle. Now this one here, they do give you, this is the base and this is the perpendicular height. Okay, so that's the diagonal. So for this triangle here, they've given you the base, which is 16, and the height of it is just simply equal to 30. And then because it's a triangle, you just go and half this. Okay, so times that through by half. That's going to give you a 16 by 30, 300 at 150, 450 at 30 is 480. So you've got 480, half of that should give you 240. So the area of the triangle is 240 cm squared. That's fine, 240 cm squared. Now to get the area of the rectangle, I need this length over here. So I've got to use Pythagoras to work out. Okay, if I look at this triangle over here, I've got to use, that's really not very representative, is it? Let's go over here and then down here. And there we go, and there we go across. Okay, there we go. There we go. If that's 30 and that's 16, that's going to call this the missing side x. I've got to use a bit of Pythagoras here to work out this side here. And this side x, the missing side, I've called it, is the hypotenuse c. The two shorter sides are going to be a and b in either order. And again, always write out your Pythagoras formula. A squared to b squared gives you c squared. Well, a for us is 30, so 30 squared add b squared, which is 16 squared, is equal to c, which is x squared. So I've got 900 add 256 gives me x squared. If I add those together, that's 1156 is equal to x squared. I'm going to assume here that's going to give me some sort of nice whole number, but I'm not too sure. Is 1156 a square number? We're going to find out now. So I'm going to go and square root 1156. Gives me 34. Yeah, perfect. I thought it probably would do. So x is going to be equal to 34. So now this length over here is 34. To get the area of the rectangle, okay, so that's the triangle, the area of the rectangle. Just make it really clear here, right? The area of the triangle was equal to 240. Now the area of the rectangle is going to be equal to 52 times by 34, which I'm going to put it into a calculator just to make it a bit quicker. So 52 multiplied by 34 gives you 1768. There we go. Gives us 1768. So the total area, we're going to add those together, which is going to be 240 add 1768, which is going to be 1968, which is 2008, I think, 2008 centimeters squared. Let's double check the mark scheme there. Yeah, that looks. I'm just going to put it into the calculator to double check, but that looks absolutely fine to me. This here is looking like my answer. So let's double check this. I've got 240 add 1768. 2008, perfect. We're looking good. Okay. And then I believe, right, we've got one more question, which is question number 27. Okay, which is looking like a nice question again. It says the following. The diagram shows a design for a zip wire. Okay. The zip wire will run between, so here's the zip wire, will run between the top of two vertical posts at AB, which is here, and CD over here. So this is your zip wire. Work out the distance AD, so you want to work out this length here, A to D. Now, I'm going to look at this and think, well, okay, if I put a line going across over here, this will create me a right angled triangle, which will probably be useful. Okay, now, is that going to be useful? Yeah, it is. Now, if I kind of get rid of this again to make it clearer, this whole angle here is 95 degrees. If I go and put this line going across over here, okay, this angle must be 5 degrees. That's that little angle. I'm going to redraw the triangle over here. This tiny angle, okay, over here, this must be 5 degrees. Now I can work out the length of this part over here in my right angle triangle, because if the whole thing there is 6.5 and that's 2.3, this length must be equal to 6.5 take away 2.3, which is going to be 4.2. So this length here must be 4.2. 4.5, 4.2, good. And I'm trying to work out the length A to D. Okay, work out length AD. Now I'm trying to find that. Let's go and call this side here X. And now, because I've got an angle and a side, I can work out this missing side using trigonometry. So let's go and label up our triangle. If that's my angle there, the side opposite the angle, we go and call it the opposite side. That's the hypotenuse, and again, this is the adjacent, but there's nothing labelled on that side, so just leave it blank. But what I would go and do now is write out my SOHCAHTOA. And again, which one of these do I need? I've been given O, I've been given h, which is O and h, which is the first one. Okay, so now what we're going to do every single time until we've nailed this is I would draw out my triangle for this. Okay, there we go. There we go. Nice. Where the middle part, the O goes at the top of the triangle. So the O is going to go up here. The S here, okay, it stands for sin of the angle theta, and the H goes down here. Now we're trying to find here the hypotenuse, because that's X, that's the side length A to D. So what I'm going to go and do here is cover up H with my finger. So put your finger on the screen or cover it up and go and say that, well, H is going to be equal to, this time, opposite divided by sine theta. So O divided by sin of the angle theta. So I've put my finger over the H, I've covered it up and said H equals to O over sine theta. These equation triangles just make it much easier to get the right equation. And now we can just go and put in our values because H is equal to X, which is good, that's our missing thing. So X is equal to O, which is 4.2, divided by sin of the angle theta. And the angle here is equal to 5, so sine of 5. So X is equal to 4.2. 4.2 divided by sin of the angle 5, which is equal to 48.2 meters to 1 decimal place. It doesn't ask you to round to anything specific, so 48.2 is going to look pretty good to me. 27 is perfect. Okay, so there we go, and I believe that is it for section number 4, isn't it? Good. So perfect. Okay, section 4 is complete. On to section number 5 next, which is looking at exact trig values. Okay, I'll see you there. Perfect.